Hi, I am Faiz, and I will introduce the work project that we had work on. So the first thing first, that we have investigated the cases at Sungai Kesang, which the problem is the problem of soil deformation. Before we delve deeper into the problem of soil deformation, we need to understand the definition of soil deformation within the geotech problems. So the first thing first, soil deformation refers to the alteration or change in form or volume in a soil. So there are four usual geotech problem in soil deformation. The first one is swelling, which happens when water enters the soil in large quantity, in which it will increase the volume of the soil. And the second one is creeping, in which the soil slowly move sidewards. And heaving refer to the upward movement of the soil, where the soil slowly move up and up. And then lastly, we have plastic flow, in which a highly plastic soil will act as plastic under a constant force, shear force. So all of the soil deformation usually happens when outside force exerted to the soil. To avoid the soil deformation problem at a site, an engineer will employ several solutions to dissolve the problem. One such solution is that the engineers will employ micropiles, in which a small cylinder will be dug down under the soil which have soil deformation problem. And after it will be dug down, the cylinder then will be filled with concrete or other materials to make the pile stronger. The piles will act as a compound in the soil, which will strengthen the soil integrity. So for the next solution, an engineer may use jet grouting technique. It a bit different from micropiles, in which case jet grouting will dug the cylinder first and fill it with concrete. We can see from the graph, jet grouting is usually bigger than micropiles, whereas jet grouting is used at a certain places, while micropiles is used at many places, with them being more in numbers. So lastly, we have the expanding geopolymer solution, in which an engineer may inject geopolymer into the soil. And after the engineer have inject the geopolymer, it will start to expand the geopolymer, so the soil will compact on itself. The geopolymer may expand at 10,000 Pascal of pressure and may make the soil 5 times stronger than the original strength. So that is the solution for the soil deformation problems.
Hi, my name is Khalid Hamoud Mohammed Sayeghi, and I'm going to this metric number AF21302. I'm going to discuss methodology. There are various measures that must be taken in order to complete the research goals. These processes are essential because they provide a more thorough grasp of the process and workflow. The proper material models had been chosen after reading and comprehending the pertinent literature materials, and the parameters needed for analysis had also been established. The information was gathered from the Sungai Kesang flood mitigation project, where it will be utilized to recreate the site conditions. The pore log, which displays the site soil profile, the location of the porehole, and the standard penetration test values of several strategic soil layers, served as the source of the data. We have to determine that the soil type is clay and sandy clay by taking samples from the site using the following methods, and by carrying out tests to determine the mechanical properties of the soil in situ. The methods we used are used in the soil investigation. Investigation is needed to determine the subsoil, which include the soil type, strength, soil structure, moisture conditions, and presence of root. The purpose of the soil investigation is to determine the bearing capacity, seasonal volume changes, and other possible ground movements. In addition, increasing the number of boreholes or sufficient number of boreholes so the result of the report is more accurate to determine the problems that may occur during excavation, which can cause the soil to deform.
For the test, the accuracy of soil simulation using the discrete element method (DM) depends on how well micro-scale particle interactions mimic real-world soil behavior. Bulk soil mechanical behaviors such as stresses, deformations, and volume changes are important for engineering design and prediction. These behaviors are often referred to as geotechnical characteristics. Knowledge of peak stresses or soil strength may be sufficient for some applications, but more comprehensive information is needed for others. Triaxial shear, direct shear, and tensile strength laboratory tests are frequently used to determine soil geotechnical parameters. Penetrometer force is frequently used to evaluate in situ soil mechanical characteristics as a result of penetration depth measurements or other in situ tests. The microscale DEM parameters that generate the best fit between physical soil bulk mechanical behavior and DEM are identified using DEM simulations of physical geotechnical testing. Simulations of engineering problems can be evaluated using available data and used to predict mechanical behavior in situations when data is not available after an ideal match between DEM and physical soil bulk behavior is discovered. Because DEM simulations provide emergent solutions across a wide range of situations, this is achievable.
Okay, hello guys, my name is Shavinash and my matrix number is AF210104. So I'm now going to talk about and explain further in detail about the soil properties. So soils in this project are sandy clay soil and clay soil. Classification of soils based on textural triangle of soils. So we actually classify the soils based on a textural triangle. So soils with more than 30% clay are clays, soils with 20 to 30% clay are clay loams, soils with less than 20% clay are loams unless they have more than 80% of sand, soils with more than 80% of sand are sands, soils with more than 50% sand are sandy, and soils with more than 50% slip are slitty. Slitty is like sandy clay soil. So let's take a look at the characteristics of sandy clay soil. So these soils have a higher propensity to create a crust which is frequently quite hard than sand soils. Over-tilling can cause them to compress, which reduces their capacity to absorb water during periods of precipitation. Now we are going to take a look at the characteristics of clay soil. So clay soil, there are so many categories. So let's take a look at the first one, which is 10 to 25% clay. These soils are different from the ones previously mentioned in the crusting, can rather be severe. Often the crust must be broken up since it is so rigid. And next we will take a look at the 25 to 40% of clay. Although these soils have strong capacity for capillary action to carry water from deep layers, the pace is sluggish. Therefore, plant water needs are not satisfied by capillary water. These soils have more pronounced soil agglomeration and a darker color. Okay, and lastly, clay soil, which consists of 40% of clay. Although the majority of the water is securely bonded and not accessible to plants, heavy clays have a high water holding capacity. Compared to other mineral soils, humus concentration is frequently greater. So clay separates during freezing winters and forms a very helpful aggregated structure in the topsoil layer. The clay can become extremely stiff and challenging to work with if it dries out without being frozen. Thank you, and that's all from me.
Assalamualaikum. Hi, my name is Muhammad Sadiq bin Hamidun. My meter number CF210360. So today I will continue with the establishing and comparing the SI report from the result of soil in the Sungai Kesang Johor. So there are various measures that must be taken in order to complete the research goal. So the proper material model had been chosen after the reading and comprehending the pertinent literature source. And the parameter needed for analysis had also been established. So the information was gathered from the Sungai Kesang flood mitigation project. So it will be utilized to recreate the site condition. Okay, we continue with the total ground surface settlement. So the effect of load and groundwater level on the settlement behavior. As we can see in this figure, the influence of the load and groundwater table on excavation displacement is demonstrated that the larger is the load and the greater the settlement. Change in groundwater level had no substantive impact on settlement. Okay, next we continue with the excess pore pressure. So the effect of fluid and groundwater level on the excess pore pressure. The position was chosen since it is immediately beneath the surcharge load as well as beneath our recommended groundwater table value. In this figure, we can see the instant with the largest extra pore pressure at a surcharge value of 30 kilonewton meter square. Furthermore, the groundwater table had 1 meter from the surface display the largest value of excess pore pressure, which is instant 20. Okay, next, the deformation pattern, and it is deformation pattern from FEM analysis. So we can see in this figure the deformation pattern of the soil strata from the FEM study at the consolidation phase 3. This deformation pattern is only applicable to case 20. This is due to the fact that it has the highest value in terms of settling and excess pore pressure. So the remainder of the example were nearly identical to case 20. The distort mesh produced the highest value of 0.16 meter. Yes, we're still in the deformation pattern. So this is the deformation contour from PEM analysis. As we can see in this figure, the deformation contour of the soil of layer was shown. It also shows the consolidation phase 3 for case 20. So the maximum value of its incremental displacement was 3.496 times 10 meter, and the minimum value of the incremental displacement was negative 0.01511 meter. So that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azizul Hakim bin Yusof, nama matrik CF220152. For the summary, we can assume that the condition of soil from excavation work at the Sungai Kesang Johor can be analysed by the correlation of physical properties with mechanical properties. For the standard penetration test, we can conclude that the 30-degree slope angle is the successful rate. Referring to DAS 1998, it said that the most of these application clay soils are compacted at maximum dry density and optimum moisture content. The problem deformation from excavation work come with the solution for two methods where we use macropiles and jet grouting and also expanding the geopolymer. For these two methods that will be carried out to achieve the maximum strength of the soil and keep away the soil from the deformation from the excavation work. This from the Tentacles and Greenwood 1998, it said that the ground with the high cohesion showed that the effective diameter of soil creep will decrease with
increasing the standard of the penetration test and values.